In this problem, I need to solve the equation below on the interval from 0 to 2 pi using the graphing calculator. My equation is secant x plus 2 equals the cotangent of x. Now, in order to do this, I'll need to make sure that my graphing calculator is set up properly. Notice that whenever the problem asks you to use the graphing calculator, that's a good indication that you're not going to be able to do this by hand. The first thing I need to do is to press mode in order to get to this screen where we can make sure that the calculator is set up properly. So here I've got the calculator in radians, which is what I want. I know that I need to be in radians because we're solving on the interval from 0 to 2 pi. So that's radian measure rather than degree measure. If they wanted you to use degrees, then it would be 0 to 360 degrees. So we're all set up for radian mode, and press second mode to exit from this screen. Now I press y equals to type my equation in. And what I'll do is I'll make each of the sides of the equation its own separate function. So we've got y1, which is going to be secant x plus 2. y2 is the cotangent of x. Of course, we don't have a secant and a cotangent in the calculator, so I make that into 1 over cosine x plus 2 and 1 over tangent x. Second mode to exit from this screen. Now I need to set up my graphing window. So I'll press window to get to this screen, and I'm going to change x min to negative 0.1 and x max to 2 pi plus 1. The reason for doing this is because since my interval goes from 0 to 2 pi, but I might have a point of intersection right at 0 or right at 2 pi, I want to put in a little bit of a buffer. And I put in a pretty small buffer, just 0.1 on either side. And if you feel like you need more of a buffer, you could just add a little bit more to those. So it's not a science, it's more of an art deciding how much buffer to use there. I typed in 2 pi plus 0.1 into this space, and then when I moved down using the down arrow, it automatically calculates that value and turns it into 6.38, etc. Everything else I left the same, and that worked out well for this particular problem. You can also change the limits for y if you feel like there might be a point of intersection above or below your graph screen. Once I do this, I'm going to go directly to graphing. I'm not going to use the zoom feature at all. You can zoom, but I like the accuracy of getting these fairly precise limits in your graphing window. So now I'm going to actually look at the graph. Now I've pressed graph and I can see the graph. The nice thing here is that I can see the two separate functions because I've graphed them in different colors. That's nice if you have a calculator that graphs in color. If not, then you're really just looking at the two graphs and looking for points of intersection. So it's not absolutely necessary to have contrasting colors, but it's nice if that works for you. So what this tells me at this point is that I have a solution. I'm zooming in here a little bit. So I've got a solution here, and I've got a solution here. And it almost looks like there's a solution here, but there's a little bit of gap in there that I just drew over. So let's get rid of that. So if you take a look here, you can see it doesn't look like it's actually touching, but if I wanted to, I could do a zoom box and just double check and make sure that there is actually a gap in there. So I'm going to be looking for these two solutions. All right. I need to find the point of intersection of my two functions because that's where they'll have the same x value. And so that'll be the solutions for the equation. So my point of intersection I can find by pressing second and trace to get to this screen, and then I choose number 5, which is intersect on the list. And to get back to the graph screen, you're just going to hit enter. Now I have my graph screen here, and I've actually gone through a couple of the steps. So the first thing when you're doing the point of intersection, the calculator will ask you what functions it is that you want to find the intersection of, because you could have 10 functions typed in. So we select our 2 functions. Here's y1, which is the secant x plus 2 part, and then the one in red is 1 over tangent x, which is of course the cotangent x part. And so I've pressed enter just automatically for those 2. Those are the only 2 functions I have in the calculator. And now it's asking me for a guess. So I've moved the cursor using the left-right arrows, obviously the left arrow here because we're already over on the left side, for what is the guess for my x value. So what is my guess of the solution? So this should be fairly close, but we'll let the calculator actually get a little bit more precise. So once I get fairly close to this, I press enter again, and the calculator will come up with a solution. And here's my point of intersection. So here we have it, and my x value is 0.31660136. And then I can go through that process again and find my second point of intersection, which is here. And I have my second solution. And since we've got the complete interval graph, I'm not worried about there being other solutions. I mean, I can check this, but it's pretty clear that there's a gap there. So that's the end of that problem.